drawn out step process. So it's chapter 4, section 2. Graphing polynomial functions. What it wants you to do is, if I gave you this polynomial, and you factor it, it equals, you can find the x-intercepts. You need paper? That's paper if you need some paper.
No, I have them.
Okay. Yeah, that's what, whenever I see those, I always grab as many as I can, just for that reason. So what this thing is looking for is, what are my x-intercepts? At positive 2, -1, and -3. So what they want you to do here is this. They want you to use a little table. My intervals. This is how they want you to graph it. What's my first interval? My first interval is from -infinity to -3. From -3 to -1. From -1 to +2. Right, and then, yeah, so we have, yeah, exactly. So yeah, so actually, we don't have to do any of that stuff, because now we know what's going to happen here, because we know at +2, it has to cross it, because multiplicities are 1. But what they want you to do is, now they want you to take test value, give me a number inside that interval, let's say -4. Plug it inside your function. So they want you to do this. And if it's positive, it's above the x-axis. If the answer is negative, it's below the x-axis. You see all that extra work they want you to do? So from -2, then at 0, at 3. But you don't have to do those, because we know at those intercepts whether it's going to cross or bounce. But that's what they want you to do. So I just saved you a whole bunch of time and effort doing that. Sketch the graph of this one. 2x to the 4th plus 3x cubed. What's the first thing you gotta do? Factor. What do they always have in common? How many x's?
2 x's?
This one has 4, this one has 3. They have to have more than 2 x's in common. They have 3 x's in common. What's that? You just copy it. That's why she said it so quietly. And he just took a guess that you're usually right. So yeah, they both, It's always, if you have two or more, and they all have the same they all have x's, always look for the smallest exponent, because they all have to have that in common. So what are my zeros? So at this point, take anything that has an x, set it equal to 0. So x cubed equals 0, negative 2x plus 3 equals 0.
So those are my zero.
Take the cube root of both sides. So x is equal to 0. That's 1, 0. And then move the 2x over there. So 3 equals 2x. So x is equal to positive 3/2, or 1 1/2. Those are my x-intercepts. So my x-intercepts are at 0 and 1 1/2. At x equals 0, what's my multiplicity? 3. So does it, well, what's the end behavior? Is it gonna go up or down, the same or different, or what? Is it same or different first?
Um,
End behavior, do they both go the same direction or different directions? Because it's a 4, they both go the same direction. Do they go up or down? Well, since it's a negative 2, they both go down. And since both of their factors have odd exponents, they bounce. It looks something like this. Up, down. It's going to have a squiggle in there somewhere. The only reason I know that is because it's a fourth order equation. Yep. Ah, they're both odd. Why am I listening to you guys? They cross. They have to cross the x-axis. This not bouncing, I can't do that, because that's only if it's even. So since they're both odd, I know it has to cross. And it has to go back down and cross there too. Look at another example, a little bigger one. Two x cubed plus x squared minus 8x minus 4. Graph the polynomial. What's your first step?
Said,
What's that going to find? If you set the x equals 0, what's that going to find? The y-intercept. The y-intercept is always the constant. But since we have 4 terms, what's the only method we know? Grouping. So put parentheses around the first 2 and the second 2. numbers or terms. Factor what you can. What are the can factor out of the first one? X2. So I have 2x plus 1. What can I factor out of the second? You have to take out the negative. -4. So to see what goes inside the parentheses, divide both of these by -4. So the negatives cancel. 8 divided by 4 is 2x plus 1. Remember, we have to make sure we can only go further if inside the parentheses are the same thing. Since these are both the same, I can factor them out. Which leaves me what once I factor them out? The coefficients. So it's x squared minus 4. Can I factor this any further? You can't stop until you get down to linear factors. This is quadratic, so we can go further. We're going to try to go further. What's it going to equal?
X plus 4, x minus 4.
No.
No? I mean, x negative 4. Then,
Look at it'd be 2, because this is the same thing as x squared minus 2 squared.
okay.
So it's x plus 2, x minus 2. And these are our 3 solutions, which is how many we're supposed to have. So what do we know about the graph? What's it going to look like? What's the end behavior going to be? Same direction, opposite direction, up, down?
Up and down?
What do you mean? Up and down. Do the ends go the same direction or different directions? Yes, because it's odd. Opposite directions. Does it go up or down on the right? Because it's positive. So we know our graph's going to look something like this. Our intercepts are where? Yeah. Yeah. Yeah, you were getting carried away there. Yes. So what's this one going to equal? Remember, opposite sign, so it's -1 divided by 2. And then -2 and +2. Where's my y-intercept? Do they cross or bounce at the intercepts?
What do we cross?
Well, here are the factors, and they're all odd exponents. Multiplicities are all odd, so they all cross. They all cross. It bounces if it's even. So this side has to go down, this side has to go up, and they cross. So it looks something like this. Yes.
After the 2x 3 plus x2, where do you get the 1 from?
Good question. Since they both had an x2 in common, I could divide both of these by x2. X2 divided by x2 is it 1? I mean, both of you are having great questions. Very legitimate questions. Oh, no. We got people online doing this and other people have finished the course already. However, some haven't even gotten that far yet. So, because this weekend, I'm also gonna send out a progress report. We're in chapter 4. If you haven't even started chapter 3 yet, I'm gonna give you unsatisfactory, or if you're at the beginning of chapter 3, unsatisfactory, because you're a little bit far behind. If you're at the end of chapter 3 or chapter 4, or you're on chapter 4, you're satisfactory. It's just gonna be, we're running out of time. We only have 2 weeks, 2.5 weeks left for Thanksgiving, and then a week after Thanksgiving
When is the final report
this weekend.
this weekend?
Don't sweat it. Nobody sees it except you. So it's just gonna tell you where you are. What's that? Keep you on track. Yeah. It'll light the fire under you. Say, okay, I have to get, especially since we're getting close to Thanksgiving.
Because I'm gonna catch up, right?
Oh, I have no doubt about that.
So I was just gonna say like, if right now they put me unsatisfactory,
But nobody sees that other than you. Nobody in
so
school sees that. Nobody.
you won't affect me in like.
No. You're
Oh.
penetrate. No, it doesn't do anything. It's just a incentive motivator.
Okay.
Incentive motivator.
Okay.
X to the 4th minus 7x cubed plus 12x squared plus 4x minus 16.
So this thing goes like the same on it. We group in
Well, we can't group because there's 5 terms here.
group of 3.
No. So for right now, since we haven't learned how to factor these, I got to give you the factors. How many factors will I have? Right. Because the degree is 4. In this case, 2 of them are x minus 2s. Because remember, the degree is 4. So what does that mean about our end behavior? Very good. Since it's an even, same direction, since that's positive. Right.
So every time it's even, that was going the same way.
Right. If the
They both go down, they both go down.
yeah, if the leading coefficient is negative, it's down. If it's positive, it's up. If it's even, it's same, odd. This is different. 1, 2, 3, 4, 5. -1, -2, -3, -4. What's my y-intercept?
And minus 16, well, negative 16.
Exactly. Good job. My zeros are at
X equals -1, 2, and 4.
what's my multiplicity in the first one? Multiplicity in the second one. And multiplicity in the third one. Why is that important? Before, yeah. So I have -1, 2, and 4. So we have the x-intercepts. At the 2 outer points, we know they have to go up because of that's what my leading term tells me. At -1, does it cross or bounce? Because it's an odd multiplicity, it crosses. What does it do at 2? It bounces because it's a 2. What does it do at 4? Now, if you look at what they wanted you to do in this chapter, you would be spending most of your time figuring out, okay, what's the intervals, pick a number, plug it in there. Is it positive or negative? You don't have to. Once you see that, but I think you have to do it anyway because those multiple part homework problems, pick a value, test, is it positive or negative? But graphing, I'm just showing you the shortcut here. Okay, the last thing of this section is what's called the intermediate value theorem. The intermediate, that's awful. That looks awful. I'm sorry, buddy. The intermediate value theorem. All the intermediate value theorem tells us is this. If your function is continuous on an interval, and if you take those endpoints of that interval, put them inside the function, so let's say here's A, here's B. It's a continuous function. Oops. Here's A, here's B. Here's f of A, and here is f of B. If they have different signs, then there exists at least one point at some value C where the function is equal to 0. If your values at A and B, if they have different signs and it's continuous, then it has to cross the x-axis somewhere between there. Make sense? A 2x plus 1. The interval of this one is -5 and 5. Is there an x-intercept somewhere between there? In other words, is there a value inside this interval where f of x is equal to 0? Well, let's try it. Let's try at -5. -10 plus 1 equals -9. So we tried it at that point. And now we try at this point. So we have 2 times 5 plus 1. 2 times 5 is 10. They're different signs. So yes, there has to be at least one place in this interval where it equals 0.
So they're different.
Simply because, only because they're different signs. Well, no, it can be. Because what if it was a quadratic equation? What if I said if A was here and B was also here and the same y value? It has the same y value. You can't tell me one way or the other. It doesn't mean it doesn't exist. It's just that we can't be sure of that. But this one, the graph looks like this. From -5 to 5, since this sign is negative, this sign's positive, somewhere between there, it has to cross the x-axis at least once. It doesn't tell us how many times it crosses or where it crosses. It just tells us that it does cross. Let's look at some examples here. What's that used for?
We'll go back. You said if they're different, that's gonna move to 0.
No, because the signs are different at both of these endpoints, at the value, the y values. That means there's at least one point between there, at that point C, where f of C is equal to 0, where it
So
hasn't.
is there any that is, I don't know how to explain myself, like.
Yours, if at both ends they're different, there's no x-intercept?
Like, one that even never be there to zero, like you don't go to zero, or it's impossible, like you would always go.
This doesn't tell that. If we had, like you said, if f of A is positive and f of B is positive, then we can't say anything about that. But it doesn't say there is no x-intercept. It's just that we cannot use the intermediate value theorem to say that there is for sure. The intermediate value theorem says that if f of A and f of B, one's positive, one's negative, then there is a C between A and B where f at that point equals 0. Let's look at these examples and maybe it'll open it up. Example 4. F of x is x cubed plus x squared minus 6x. A is equal to -4. B is equal to -2. Is there at least one real 0 between there? How do you know that?
I don't know, but I'm sure we
The
all-
only way you can be sure is if you put these endpoints. This is f of A, and this is f of B. So we have -4 cubed plus -4 squared minus 6 times -4. -4 cubed is going to be a negative answer because it's odd. 4 cubed is 64. 4 times 4 times 4. Plus -4 squared. -4 times -4 is positive 16. Negative times negative is positive. 6 times 4 is 24. We have -64 plus 40 is -24. So at f of -4, when A is -4, we get -24. -2 cubed plus -2 squared minus 6 times -2. -2 cubed is -8. -2 squared is 4. Negative is a positive. 6 times 2 is 12. -8 plus 16 is a positive 8. So what it tells us, between the numbers -4 and -2 on the x-axis, there has to be an x-intercept, at least one x-intercept. Because this one's negative, this one's positive. So between -4 and -2, this one's -24, and this one's positive 8. So the only way they can be connected is if it crosses at least once. But if they both have the same sign, we can't do anything. We can't, it may have an x-intercept, but this test doesn't work. That's all it tells us. It doesn't tell us how many or where, it just tells us at least one exists. Now, why is that important?
Also, we know in crossing.
We know it crosses, and you know there's gonna be an intercept there. Okay, how are your brains so far? That's it for that section.
So this part is really hot, this one's kind of hot.
Because